Hello friends, welcome to my channel. Today we are going to study the relationship between continuity and differentiability. Continuity and differentiability we have studied in our earlier videos. Now let's come to the theorem. If a function f of x is differentiable at a point, then it is also continuous at that point. Let's come to the proof of the theorem. Let us consider f of x be a function and is differentiable at x is equals to c. Then by using first principle of differentiation, f dash of c is equals to limit x tends to c f of x minus f of c upon x minus c. Take this as equation first. Now f dash of c, since we have taken this term as equation first, imply c minus c. When we put x tends to c, we get x minus c. C minus c is 0. This whole term reduces to 0 and we get f dash of c is equals to f of x minus f of c. Take this as equation second. Now let's come to when x is not equals to c. F dash of c is equals to, when x is not equals to c, f dash of c is equals to limit x tends to c f of x minus f of c upon x minus c. Take this as equation 3. Now this whole term is multiplied by this f dash of c x minus c is equals to f of x minus f of c. Take this as equation 4. Now taking limit on both sides of the equation 4, we get f dash of c x minus c, limit x tends to c f of dash of c x minus c, and limit x tends to c f of x minus f of c. When we take limit x tends to c, this whole term reduces to 0. This whole term reduces to 0, and when 0 is multiplied by this term, we get whole term is 0. Now the remaining term is on right hand side is limit x tends to c f of x minus f of c. We get limit x tends to c f of x minus limit x tends to c f of c. Now the negative term on right hand side goes on left hand side, it becomes positive. Therefore limit f of x, limit x tends to c f of x is equals to limit x tends to c f of c. Here the function is differentiable because the limit of the function exists and is differentiable at point and is continuous at point x is equals to c. Therefore the function is continuous. It means that here we have taken the function is differentiable and we get the result the function is continuous. It means that every differentiable function is continuous. Now but a note, every differentiable function is continuous, but every continuous function need not be differentiable. Now let's come to one example of it. Let f of x is equals to mod x. Therefore f of x is equals to mod x is equals to minus x for x is less than 0 and x for x is greater than or equals to 0. Now by using first principle of derivative, we get f dash of x, f dash of 0 is equals to f of 0 plus h minus f of 0 upon h. On putting the values, since we know that f of x is mod x, therefore f of 0 plus h is mod 0 plus h minus mod 0 upon h. Limit h tends to 0, we get mod h upon h for limit h tends to 0. Since mod h is equals to minus h for h is less than 0 and h for h is greater than equals to 0. Now take the left hand limit of the function. We get minus h upon h is equals to minus 1 and right hand limit of the function is is 1. Therefore, the left hand limit and right hand limit of the functions are different. Imply limit h tends to 0, 0 minus left hand limit is not equals to limit on right hand side. Therefore, the function does not exist. Therefore, the function is continuous at x is equals to 0 but not differentiable at x is equals to 0. Thank you for watching. For more videos, don't forget to like, share and subscribe the channel. Thank you for watching.